My name is Emily Weber. I'm a machine learning specialist at Amazon Web Services. So today we're going to talk about Autopilot, Amazon SageMaker Autopilot. So you might be thinking to yourself, how do I move faster on basic machine learning problems like regression and classification? I mean, we see these cases over and over again. There's a lot of technology and methods that are already built. Can I just use those automatically? And so the answer there is now Amazon SageMaker Autopilot. So Amazon SageMaker Autopilot. So we're going to start with your data in S3. Again, for regression and classification problems, so your data is already labeled and it's already in a structured format, we're going to want your data in S3. Fortunately, you don't need to have your data featureized quite so much because Autopilot is going to handle featureization of your data for you. But let's start with your data in S3. After that, we want to pick your target column. So in this case with Autopilot, we actually need a header. We need to make sure that we're including a header on our data. And then we're actually just going to point to that target column in the header file when we set up the Autopilot job. And then really the last thing that we need to do is run on Amazon SageMaker. The rest of the content is handled. So Autopilot is going to analyze our data. It's going to suggest features. It's going to perform principal component analysis and other data reduction strategies. It's going to tune large volumes of models and then ultimately find the best one for us. And so what's exciting is that all of this content is generated for us. Autopilot is generating notebooks for every stage of the process. So again, that's going to handle data exploration, what we call candidate generation, or Autopilot's ability to generate potential models that it will tune and train downstream. We're also going to get a data transformation script generated for us. And so this script we can use to modify, right? So when you are looking at a candidate that was generated for you, you might think, geez, I like this approach, but I actually want to add, 2 or 3 more steps that are a little bit more custom to exactly what I was looking for. And Autopilot is going to let you do that. So again, it's going to explore feature and model strategies. And then it's also going to provide contextual recommendations to you. So it will look at your data and say, hey, based on this distribution in a certain column, I really think we should drill into the domain, knowledge base in a certain area, so that we can get more clarification about why the data look like this in a certain case. And so good times to pick Autopilot versus not so good times. So again, when the problem that you're solving falls squarely into either classification or regression, I would strongly recommend starting with Autopilot. Again, Autopilot is going to automatically handle a lot of the undifferentiated heavy lifting of machine learning problem solving for those two categories. And so there's no question that you'll be able to move faster and add more value to your business and to your customers by leveraging Autopilot. If you have some missing values, it is absolutely okay to use Autopilot. Autopilot is actually going to explore what we call imputation strategies. So it's going to fill in some of those missing values given an imputation strategy that seems like the most reasonable choice given your data. And also, you're going to want to pick Autopilot when PCA is okay, which is to say when you're comfortable with a data reduction strategy that's going to start with, say, a couple thousand feature columns, but then actually reduce those down to a smaller width so that it's more amenable to most machine learning algorithms. Cases that are not such a good pick for Autopilot at this point in time would be when the problem that you're trying to solve is heavily vision, text, or sequence based. So again, if you're leveraging vision data or text data or data that seems to fall into a pretty clear sequence category, then you would be better off bringing other models or exploring, other modeling strategies that have been developed for that specific problem, Autopilot is not going to be your best choice there. If your data is mostly missing, which is to say if you have only a few data points for certain columns, you would be better off by just dropping those columns, or by spending some more time figuring out why that data is missing before plugging that into Autopilot. If you need feature interpretation up front. So let me be clear, there are ways to map your featurized data back to your training data, but if you want this immediately, right, out of the box, then you might want to just go straight to training XGBoost or training Linear Learner, and then tracking some of those feature transformation strategies yourself. I say this because, again, you can do it, but it just is a little bit challenging. So if you need that feature interpretation up front, I definitely recommend just going straight to one of the built-in algorithms. Also, if you need pre-trained models, so if you are leveraging a solution where you're planning on using, say, like a pre-trained VGG or some other pre-trained model, and you want to combine those models, that would be a good candidate for SageMaker training jobs or SageMaker inference pipelines, but potentially not for Autopilot. Couple things to remember. So you still want to include as much domain knowledge as you can in that feature set. So definitely still want to have those rich collaboration and brainstorming sessions with your domain experts who can share more information with you about the area that they're actually experts in, so that you can bring that knowledge base back into your feature set. You may be surprised once you get started in the length of time that Autopilot will take, but I would encourage you to be brave, right, and to last, to persist. It is worth it in the end. I will say that the models that Autopilot produces on average are pretty impressive, and that's because the methods that it's using are pretty robust. So you might think, geez, I'm waiting 20 plus minutes here, what's going on? But if you were building this yourself from scratch, right, case after case after case, you're probably looking at multiple weeks of work. So Autopilot is actually saving you quite a bit of time at the end of the day. And the last thing to know is that, remember, you're getting all of that code generated for you. So if you are concerned about wanting to make changes to Autopilot, just remember you will definitely get all that content generated, then you can modify it. So let's take a look. Right, this is obviously SageMaker Studio. Just remember, so over here on the left-hand side, I'm going to hit this little file button, and that shows me where we are. So that's the root directory. Then we're in SageMaker Examples. We're inside of this Autopilot folder here, and then I'm looking at Autopilot Direct Marketing. And then we're just going to open that, and then I'll just close this out, just with another click. So let's step through this. So I'm just going to cruise down here, and you know what? We're actually just going to run all. So I'm going to go up here, I'm going to hit run, and then I'm going to say run all cells. And then this is just going to execute this notebook. So let's check it out. So the first part should look very familiar to most of my SageMaker users. If you're new, then just take a quick look at some of the other content that we have. But essentially, we're going to import the SageMaker SDK. We've got our region specified. We've got our buckets, all the good stuff. Down here, we're going to want to download a data set, right? So this is a wget command out to the internet. Then we're just downloading this data set onto the EC2 instance that this domain is giving us visibility into. We'll cruise down. So we're going to open up that data set here just to take a quick little visual here. So obviously this is our pandas data frame that we can browse through with the target column right over here. So we've got 20 features. That's going to help us predict that target Y column. We do want to split our data. We don't actually have to split this, so Autopilot is actually going to help us in this capacity, but it is nice to keep some test data locally on the domain instance so that we can just test the model that's been identified. All right, so we've got our train and our test file. I'm going to drop those in S3, and then let's set up our autopilot job. All right, so take a look at this. So input data config. So we've got our S3 data type. That's our S3 prefix. Our URI is right here. And so that is just telling us where we copied our data previously. And then remember target attribute name. So Autopilot is looking for a header. It's looking for a header in our training data. So we want to make sure we bring that, and then we're just going to point to the target column right here. And then this is our output data config. So our output is going to go right there. And so you can specify the type of problem you're trying to solve. If you're going after regression or both multi-class and binary classification, you can just specify that. If you're not sure, you can ask Autopilot to infer this. I will say though, if you know which one it falls into, then just go ahead and specify that. I mean, there's really no reason not to. All right, and then here we're going to set up the job. And now the job is running. So actually all we needed to do, again, was point to our data in S3 along with the job config, and then we just create the job. And so we can track Autopilot in a variety of ways. If you clone this notebook, this IPython notebook file onto a SageMaker notebook instance, and if you're running it there, then it's going to be helpful to watch this so that you can monitor your job. And we'll see right here that we're getting some statuses. So the job started, and right now it's actually analyzing our data, right? So it's looking at those data attributes, and then it's coming up with some strategies. But what's nice about Studio is that it's actually going to give us a visualization here. So let's cruise over. So I'm going to look at this experiments tab, this little beaker here. So let's open that up. And let's give this a refresh. So I'm just going to click on this little refresh button. And you'll see we have a new experiment that showed up. So all of the content that happens in Autopilot will automatically populate within experiments. So SageMaker experiments and Autopilot are natively integrated in that one direction, right? So from Autopilot, it will automatically populate experiments. We have a separate video drilling into SageMaker experiments, and so if you want to learn more about that, then just check that video out. But let's give this a right click. So remember, right click because we're in Studio, and then I'm going to say describe AutoML job. And then look at this. So I'll close that out here. So SageMaker Studio is giving us this visual status bar. Actually, it's giving us a progress indicator for our job. It's showing us that the current state is analyzing data. And then the next one obviously is feature engineering, followed by model tuning, followed by a completion notification. And if you get antsy, right, and you want to stop this, then you can go ahead and hit stop. What we're actually going to do right now is take a look at a previous job that I've run. So I'm going to go down here. Actually, let's look at this one. And then I'm going to hit describe AutoML job. There we go. I'll close this out. And so this is showing up in the experiments description, actually. So the name of this experiment is AutoML banking. And these are all of the tuning jobs or trials that are associated with this experiment. So we have all of these tuning jobs with the objective performance of the model. Let's hit one tuning job. What we're actually going to do here, remember, we're going to right click, and then let's open in trial details. And so remember, I'm going to drill into this in a later video, but just know that this is here. So we'll close that out. And then we also, if we want to close this, we can do it right there. So remember, we have both a candidate generation notebook, and a data exploration notebook that are generated via Autopilot. And so here we go. So as part of the AutoML job, the input dataset was randomly split, so it was a random split, into two pieces, one for training and one for validation. Training set was randomly sampled, and the metrics were computed for each of the columns. And now we're going to analyze it. So it read just under 33,000 rows from the training dataset. We're looking at 21 columns, and Y is used as the target. They're registering this as binary classification, and two examples of the labels are no and yes, so that makes sense. And remember, we did not need to one-hot encode this. Autopilot was actually handling the one-hot encoding for us. So now let's cruise down. And so here we actually have a suggested action item. So Autopilot is recommending that we take action here, that we, in this case, verify that the input headers correctly align with the columns of the dataset. So basically we just want to make sure that our headers were read correctly, and it looks like they were, which is great. So remember, there is all of this string-based data fields here, right? Obviously we have categorical data, and Autopilot is handling that, both the categorical one-hot encoding and the numerical data by performing the scaling. And then lastly, this target column over here. So let's cruise down. So the column analysis here, so we're looking at 21 input columns. So some analysis, right? So we're going to get the percent of missing values and containing missing values such as nans, white spaces, or empty fields. And so in this case, they found one column with missing values, and it had a really high percentage, right? That's 86% missing values. So Autopilot is suggesting that we investigate this. Did we expect this many missing values, and can we actually fill those in with real data? So let's keep cruising here. So it's going to look at some of our string columns, along with some more action items. And yeah, so these are all of our columns here, and then these are the count of the number of unique items. And then some quick descriptive stats. So there we go. That should all look familiar. And so that is the data analysis, data exploration. I'm going to close that out. Now we want to look at the candidate generation. And that's right here. So this notebook is now using the information that it learned from data exploration, and it's actually suggesting candidates. And what's interesting is that the candidate is not as simple as just models or hyperparameters. The candidates are actually combining different types of models with different types of feature transformation strategies. So Autopilot is actually mapping from the correct feature transformation strategy based on its analysis to the correct model tuning strategy, which is pretty awesome. So let's cruise down here. So some environment requirements. And so we can step through this notebook here, but it's going to copy our data over. And then we have a base AutoML job name, which is right here, base config. And then the candidate pipelines. So a couple things that we can fine tune here. So we can fine tune the number of instances in addition to the instance type, the candidate pipelines that are selected, and the linked data transformation script. So the data transformation script actually lives in S3. In the S3 output path for this job, you'll find it. And actually, let's see, this is in read-only mode, so let's import this notebook here. We'll just do a quick import. There we go. And remember, we'll want to make sure we're using the data science kernel. But actually, if we wanted to inherit a kernel from another session, we could do that right here. But we'll just use the Python 3 data science kernel. All right, so now we're imported, which means we can modify this. And in particular, what I want to show you is that if you double click on this, that's where the transform script is. So that's where the README is, which will explain the content of that file. And essentially, all of it is, again, stored in S3. So if we go to the S3 path for this specific job, this AutoML job, and then look at generated module under the artifacts category, which all of this is inside of outputs actually, then we'll be able to view that script. So let's cruise down here. All right, so here we go. So data transformer. So there are going to be multiple data transformers here, and they're going to have names, right? So we've got DPP0, it's the name of one transformer. And then we've got multiple EC2 instances here. And here's the algorithm. So this is XGBoost. And so that's the training resource config. There we go. So that was DPP0, which is transforming numeric features using a robust imputer, which is converting missing values to nans. And then categorical features with a threshold 1 hot encoder. It's going to merge all the generated features and then apply a robust standard scaler. And then the transform data will be used to tune an XGBoost model. And that all happens right here. All right, so DPP1, also XGBoost, also robust imputer, also 1 hot encoder. The difference is that here we're using PCA. So first we do the robust standard scaler, and then we're going to apply a PCA. DPP2, linear learner. So now we're going to combine a combined robust imputer and missing indicator, followed by a quantile extreme values transformer, threshold 1 hot encoder, PCA, and then a standard scaler. Interesting. And then that is going to tune a linear model. DPP3, XGBoost. Robust imputer, 1 hot encoder, standard scaler. DPP4, XGBoost. And on we go. And so, in total, Autopilot is going to try a wide variety of models to find the best one, and then it's going to execute those. Remember, all of this is being generated. So prior to this, in order to tune our models, I mean, we had to actually go to the SageMaker documentation, look at the specific hyperparameters, come up with reasonable ranges, and SageMaker is just generating all of these ranges for us. I mean, this is a huge boost. And then it's going to create a multi-algorithm tuner that's going to coordinate hyperparameter optimizations across different possible algorithms and feature processing strategies using these parameters. So let's check that out. So remember, the parameters are coming in from here, and those are being supplied from this AutoML interactive runner, and that is being built up here. Remember, the interactive runner is coming in up there. Great. So then this runs. And then down here, we can actually analyze these candidates by dropping out the results as a data frame. And then here's some more information on monitoring the progress of a hyperparameter tuning job. Let's go back over here. All right, so now we're going to link the best training job with the feature pipeline. Because as you remember, oftentimes in machine learning, it's really the best features that actually lead to the best model. And so in this case, we're going to want to make sure that we connect the best feature strategy with the best model. And all of that is handled for us by SageMaker Autopilot. There we go. And so that is the candidate generation notebook. Now let's cruise back over here. So back in the experiments tab, I'm going to go up to that first job that we looked at, and let's hit refresh just to see. And then let's open this in that described job. All right, so remember this is still analyzing data, although it did just complete. So we might be getting our first feature engineering results here shortly. And our job profile is stored right here. So this is our role ARN. So if we want to monitor the execution role, if there's a failure reason, it's right here. The path to our data in S3 stored right here. And the actual objective metric response, so here's our accuracy, should be populated once the job's complete. And there we go. And so the last thing to remember is that, again, if we open this, so I can go to a trained model, just going to right click on this, and then I can say deploy. And then I can actually create a RESTful API around that model in a few minutes. And so with that, remember just a few pro tips. So number one, make sure you're bringing a header. Autopilot will not work if you don't have a header, so make sure to put that in there. Second thing, when you get a model artifact, so at the end of this job, you're going to get a model artifact, and you can load that into XGBoost, right, to look at the F scores. The thing to remember is that that artifact is going to refer to your featureized training data. It's not going to refer to the original training data set. So if Autopilot decided to run PCA or any of those other specific imputing strategies that it found, you want to know that your model is going to reflect that feature strategy. Remember, not the training data. So if you do need that feature importance, you're going to have to actually reverse engineer that at this point in time. And then the last thing you want to remember is definitely use the graphics, right? There's a really nice visualization kit that Autopilot provides that we just looked at, which is pretty awesome. And so with that, thank you very much. My name is Emily Weber, Machine Learning Specialist at Amazon Web Services. I hope you enjoyed this video, and stay tuned. There's going to be more coming out. Thanks.